Rajshahi, Higher Maths 2017, question number 6. In the picture, S is the circumcenter, O is the orthocenter, and G is the centroid of the triangle ABC. AP is a median. Now in part A it asks, what is the 9-point circle? Well, the 9-point circle goes through several points on a triangle. It goes through the 3 middle points of each side. It goes through the 3 feet of the 3 perpendiculars drawn from each vertex to the opposite side. That is, it goes through the feet of the 3 altitudes of the triangle. It also goes through the 3 middle points of the 3 line segments joining the orthocenter to the vertices of the triangle. In the diagram, it goes through the midpoint of OA, the midpoint of OB, and the midpoint of OC. So in any triangle, these points lie on one circle. This circle is called a 9-point circle. In the diagram, the 9-point circle is drawn in red. The large circle goes through the 3 vertices of the triangle and is called the circumcircle. Now we have the center of the 9-point circle is the middle point of the line segment joining the orthocenter and the circumcenter. Also, the radius of the 9-point circle is half the radius of the circumcircle, or half the circumradius. Now in part B, we have to prove that the ratio AG to GP is equal to 2 to 1. Now one method to do this is to assume the result that in the diagram the side AO is twice the side SP. That result states, in any triangle the distance from a vertex to the orthocenter is twice the distance from the circumcenter to the opposite side. Now we have that the angle SPB is 90 degrees. It's the line from the center of a circle to the midpoint of a chord. Also, the angle ADB is 90 degrees. The altitude of a triangle is always at right angles to the base. So that means SP is parallel to AD. Now we're going to prove that 2 triangles are similar. So, in triangle AOG and triangle PSG, coloured in blue and green, the angle OAG is equal to the angle SPG. They're alternate angles between the parallel lines AO and SP. Also, AGO is equal to PSG. These are also alternate angles between the same lines. And finally, the angle AOG is equal to the angle PGS. They are vertically opposite angles. So triangle AOG and triangle PSG are similar, AAA. Now that means the ratio AG over PG is equal to the ratio AO over PS, which we know is 2 to 1. So that tells us the ratio AG to PG is equal to 2 to 1. Now, if we did not know that AO is equal to 2SP, we could still prove the result. Again, we're trying to prove that AG to GP is 2 to 1. And we could use a different method. We are given that P is the midpoint of BC, so BP is equal to PC, and we're given that R is the midpoint of AB, so BR is equal to RA. We want to prove that AG to GP is 2 to 1. Now we're going to have to do a construction. Draw a line through R parallel to BC to meet AP at S. Now, for the proof, we are again going to use similar triangles. In triangle ABP, coloured in yellow, and triangle ARS, coloured in green, we have the angle ABP is equal to the angle ARS. These are corresponding angles between the parallel lines RS and BP. Also, the angle BAP is equal to the angle RAS. Now that's actually a common angle. It's the same angle in both triangles. So we have triangle ABP and triangle ARS are similar, AA. you actually only need to prove two angles are equal, because then the third pair of angles is automatically equal. Now, R is the midpoint of AB, so AR is a half of AB. And from the similar triangles, we can see that therefore AS is equal to a half of AP, and so PS is also equal to a half of AP. Now, RS is equal to a half of BP, because they're sides of similar triangles, and because P is the midpoint of BC, we have PC is equal to BP. So, RS is equal to a half of PC. Now, if we look at the triangles RSG, coloured in blue, and the triangle CPG, coloured in pink, we have the angle SRG is equal to the angle PCG. These are alternate angles between the parallel lines RS and PC. Also, the angle RGS is equal to the angle CGP. These are vertically opposite angles. So the triangle RSG and the triangle CPG are similar, AA. But RS is equal to a half PC proved. So SG is equal to a half of GP because they're similar triangles. Now that means GP is 2/3 of SP. In other words, GP is 2/3 of a half AP. So GP is 1/3 of AP. Now that means AG is 2/3 of AP, and so the ratio AG to GP is 2:1. Now in part C, in the triangle ABC, the median AP is extended to intersect the circle at F. And we want to prove that AF times BC equals AB times CF plus AC times BF. Now this is actually Ptolemy's theorem, so it is a standard proof. Now we're given that ACFB is a cyclic quadrilateral. We've got to prove that AF times CB equals AB times CF plus AC times BF, and we need to do a construction. We draw an angle with side AB equal to the angle CBF to meet AF at S. Now we can say, in triangle CBF and triangle ABS, the angle CBF is equal to the angle ABS because that's exactly how we drew it. It's the construction. The angle BCF is equal to the angle BAS. These are the angles on the chord FB on the circumference of the circle. Therefore, the triangle CBF and the triangle ABS are similar, AA. So that means CF over CB is equal to AS over AB, and if we cross multiply, AB times CF equals AS times CB. This is our first equation. Now note, the angle ABS is equal to the angle CBF. That was our construction. If we add on the angle SBC on both sides, the angle ABS plus the angle SBC is equal to the angle CBF plus the angle SBC. But that means the angle ABC is equal to the angle SBF. Now again, we're going to prove two triangles are similar. So, in triangle SFB and triangle ACB, we have the angle SBF is equal to the angle ABC. That's what we've just proved. Also, the angle SFB is equal to the angle ACB. These are angles on the chord AB on the circumference of the circle. So the triangle SFB and the triangle ACB are similar, AA. So that means FS over FB is equal to AC over CB, or if we cross multiply, CB times FS equals AC times FB. That's our second equation. Now if we add together the equations 1 and 2, we get AS times CB plus SF times CB equals AC times FB plus AB times CF. But CB is common to both terms on the left-hand side, so we can factorise it as AS plus SF times CB equals AC times FB plus AB times CF. So AF times CB equals AC times FB plus AB times CF, or just to put it in the form it originally came, AF times BC equals AB times CF plus AC times BF.